Good morning, everyone, or whatever time in the world it is, wherever you are. The great thing about online presentations is that I don't know who's there and where you're from, but looks like there's an awful lot of you that are probably locals in Europe as well. So good morning to you all. It's been a nice sunny day here in Melbourne, Australia, but it's getting to my evening now, so it's a nice comfortable time for me to be presenting to you today. I'm going to cover off a little bit around Azure Data Explorer, and it's a fairly entry-level presentation, giving us an idea of what it can do and some of the capabilities of it. Before getting on to that, a little bit about myself. I've got many Microsoft certifications. I'm a data platform MVP, have been for about 6 years now, and I'm the capability lead for data at Telstra Purple here in Australia. I've been previously involved in a lot of past stuff while it still existed, running events over here in Australia, and had many events throughout the world that I've had the opportunity to present at. Back in my Europe days, I presented a few times at SQL Bits, so that's been my fun bit across there as well. I've started with SQL Server actually way back in the last century. It's one of those cool things about where you get to talk about of your experience, and it just sounds fun nowadays of being able to say I started in the last century. So been going now for over 20 years with SQL Server and related technologies, and the great stuff now with Azure and the very additional data platform tools I've been able to play with, and Data Explorer is one of those where I'm starting to gain a bit more experience in there as well. So what we're going to cover off today, looking at our agenda, we're going to look really first of all, what is Azure Data Explorer? Where does it fit within the whole data platform ecosystem, and what we can use it for? We'll jump into a bit of how to actually get started using it, getting some data in there, being able to make use of various different ways of streaming or batch loading your data into Data Explorer. We'll then have some samples on how to actually go about that. We'll do some loading of data from a couple of sources, and we'll do a bit of querying on that and give you an introduction to the Custal query language, which is the method we use for Azure Data Explorer, and then look at some of the tools we can use to consume the insights and information that we can extract out from our Azure Data Explorer platform and make some use of that. So obviously we're going end to end from our generation of our source data all the way through the platform, and then actually seeing what we can gain some insights and value from the data at the other end as well. So first of all, what is Azure Data Explorer? Obviously the number of different platforms and services within Azure now is something that keeps growing. There's so many different offerings within there, whether it's your relational databases with Azure SQL or Managed Instance, Cosmos DB, Synapse Analytics. There's so many different parts to it now. So where exactly is Azure Data Explorer? What does it offer us within the Azure ecosystem? And it's primarily focused around the area of data exploration. So finding out what you have within your large data sets and being able to understand what you have there and use it as the basis for then building on further applications and use cases for that data. It provides very low latency ingestion. We can scale it up into something which can consume terabytes within a matter of minutes. We can get up to about 200 megabytes per second of data being ingested per node within our cluster. So again, we can see that can scale massively with the number of nodes in the cluster as well. It provides a fast and basically a read-only style query with very, very high concurrency across the data. And again, one of the benefits there of consuming and querying across those vast amounts and sharing that out and having multiple users able to actually consume those queries at the same time. Some of the stats around that are things like querying 1 billion records in less than 1 second. And that's based upon it being either something that is completely structured in your data format or semi-structured like JSON, CSV type data from there. We can start to search through those data sets, looking for specific terms, doing calculations on that data, giving us some vast scope there to analyze and see what our data is doing. It's very well suited for time series analysis. So creating and analyzing thousands and thousands of time series per second. And it allows us there from that with the various ingestion opportunities to do near real-time monitoring on our data sets there and workflows. being part of Azure, it is fully managed. It scales with your needs automatically through the platform effects there. It's global availability. We can have that redundancy across Azure regions with it as well. So there's some really great ways of spreading that out across your organization. And you also pay for it by the hour, not by the query. So you can run as many queries, consuming as much data as you want, and you're only paying for the actual resource level that you need. So what you set up as your cluster and the amount of storage that is within there. Your storage can be set with flexible retention. So we're not looking at this as being like your data lake. We're not having it in the same manner as that of having that ongoing retention of your data there. You're really looking at it, pulling in, what do I need to look at to do my analytics on the data here? Whether that is, I only need the last 3 months worth of data, for example. I perhaps only need the immediate data from a streaming IoT system. All of that flexibility is there with the platform and allows us to do what we need to explore our data and provide our insights out from there. And the Azure Data Explorer, the engine that is within that, has been reused already across many of the other Azure services. So it's the service that underpins things like Azure Monitor, Windows Defender, the Azure Advanced Threat Protection that's built into SQL Database, for example. All of that is built on the analytics available within Azure Data Explorer. And it provides a number of ways to then integrate with that data as well. There's endpoints there for a REST API. It uses TDS, so we can use the same sort of querying endpoints there. There's ARM endpoints to be able to deploy into it, and numerous client libraries as well, so you can build your own applications on top of it and have the great flexibility there. Where we see the primary use cases for Azure Data Explorer, IoT is probably one of the biggest ones. So being able to ingest these vast volumes of data from billions and billions of devices and sensor readings coming in per second, being able to then query across that and pick out your insights and make use of that data is obviously going to be very important from there. It's a very strong contender into that area. Big data as well, when we start looking at the vast volumes and being able to get your queries to run across that in an efficient manner, in a quick way to pull out what's happening there, what trends do you have, what patterns and anomalies might be there in your data, and have that ability to then pull out the information which may be leading into your machine learning algorithms and building your models from that as well. All of that through the initial exploration in Data Explorer to work out what insights you have and then turn that into something of value. Looking at things like log data as well. How do you pull out where there is the interesting aspects there? So perhaps around security logs, massive input of data coming in. How do you find the bits which are your anomalies and pull those out in an efficient manner? And because of all the interfaces that there is available to it, it becomes something then that you can pull out and use to underpin your SaaS application. So we've got that coming in from all your multiple customers, all with their own part, and you're pulling that together into one area. Being able to embed that into your applications, and use that where you can sell out that service to ingest and analyze vast amounts of data in near real time there as well. It gives you that opportunity to provide things back to your customers that's personalized to them, so they can look at their aspects of the data and see the trends from their part compared to everything else. There is a good spot for it within the modern data warehousing workflow. So nowadays, where you're looking at it based upon your data lake, so your stored area there within the diagram, if we look at that, where we've got our big data store there, that'd be something like your Azure data lake. From that, you've got all your various systems feeding into it, and we can use a number of ways to ingest that. They can be pushing in. It can be something from perhaps your IoT feeds, your social feeds, pushing into the endpoint and loading things into the data set there, or something like Azure Data Factory that can be working in a batch-based process, again, to pull that data in and land it into our data lake. Now, before we've actually worked out what we want to do with that data, we don't yet know how are we going to have, for example, our ML models. We haven't built those yet. We haven't worked out how our data sits for our analytics. What do we want to serve up for things like our reporting and analytics out through something like Power BI? At this initial stage, we might just want to see what do we have, what can we infer from the data, where can we pick out our insights and understand what's there already. And that's where we then hit in with our exploration phase within here to work out amongst all our data sets, how can we relate them together? What do we need to do in terms of processing to pull that together before we then move on to the further levels of our analytics system there as well. So it's kind of that initial bit around where it fits into the ecosystem and some of the use cases around that. The next bit I want to look onto is just, how do you get started using it? How easy is it to get up and running with Azure Data Explorer? And what are the components that actually build into it? The first bit we'll start with is actually just building out our cluster on Azure itself. And again, at this level, you've also got the flexibility. So you need to start thinking around how you're going to be using it, what sort of volumes that you've got, what level of concurrency you need with your query. So how much processing and power do you actually need from that? Because what first of all it gives you is at the compute level. So really what you're building up from, there's varying levels of VMs that can underpin your cluster there. So they can range from slow end stuff like 2 vCPUs with only 75 gig of memory per machine, all the way up to some massive machines that have got 16 CPUs, 4 terabyte cache, 112 gigabyte RAM. And then we can start to decide how many nodes there are within our cluster as well. So you can see from that we've got both the vertical and horizontal scaling within the cluster itself to start with. We can include things like availability zones to improve our redundancy across the cluster as well and with our data. And then we need to decide how that is going to scale as we need it. We can set various bits of optimized for auto scale, or you can have it all manually controlled so that you've got complete fine-grained control over where you manage it, what costs you're going to occur within that. So at that point, you're going to work out, what is your initial, number of instances that for the nodes that are going to set up your cluster there. The next bit you go from there is then setting up your databases. How do you want to treat that data? Do you want to enable or disable streaming ingestion, for example? Do you need to purge your data out on a regular basis? Do you remove the whole thing, or are you working on just incremental parts through there as well? That may well be very important when you're looking at data sets that may include personal information. So obviously things around GDPR, for example, you need to be thinking about what data do you store in there? When I actually purge that, do I completely remove it, or is it a soft delete from there? So what am I actually doing with those records as well? It's important because the process around that, when you're actually deleting data, can take a significant length of time. It can be quite a resource-intensive process in the background. And when you purge it, and then once that starts, it's actually irrevocable as well. So you can't stop it partway through and go, oh, I made a mistake there. Let me just, worry about what's gone, but retain most of my data. Once you start that process of purging it, it's going to be, all of it that's going to go in the end there. The option then for the streaming side of things is really, if you are going to use that, it can enable the very low latency part between ingestion and query. So how quickly do you get it through from your initial endpoint of loading the data through into that being available for querying from your system? The streaming operation can be as quick as less than 10 seconds from the point it reaches your endpoint to being available then for querying. However, be aware of what your rate of consumption is going to be like. If you are bringing in a larger amount of data on a frequent basis, so perhaps up to maybe a limit of 4 gig per hour, then you're okay with that. Once you get beyond that, the streaming part of it's probably not optimized. It's going to start to get a bit of a lag into there. You probably then want to start looking at more of a batch and bulk-based ingestion process with that. The streaming side of things works really nicely with things like Event Hub, IoT Hub, pushing things in directly through the custom client libraries and how you build into there. And you've also got fine-grained control over the virtual network that the cluster is going to sit in. So if you wanted to plan out your security around which components access where it can come in from, where your access is, again, you've got all the ability around that to manage that. So let's have a look at the basics there. So if we come into our Azure portal, let me make this a little bit easier to manage. Just with my screen here, it cuts off a little bit of it, so let's make sure we've got everything from there. So if I come into the Azure portal, and let's look at Azure Data Explorer clusters and how we go about setting this up. So I have one in play already, but let's look at what happens if we want to add a second cluster here. So the portal wants to be a little bit flaky with me, but that's all right. So first of all, the standard bit of anything in Azure, what subscription are you going to create it in? What resource group are you going to put it into there as well? Let me stick it into my demos resource group here as I go through things. And again, your standard restrictions around naming of the cluster. So again, with most Azure things, there is a limit as to what you can do. On this one, there's this restriction of it being letters and lowercase alphabet characters only. So, and again, it will need to be that level of uniqueness through things on there. So let's give it hopefully a unique name on there. Excellent. I've got the scope around all the regions, and it's generally available pretty much in every single Azure region there. So we've got that scope of, again, looking at where we want to put that in. I'm going to pick my local one here in Southeast Australia. At the moment, the V3 engine, there's previews, so there's changes coming from there. At the moment, I would go with just sticking to the G8 version, so we'll leave that switched off. And then this is where we start to look at, what is our workload going to look like? Are we going to do either bigger data sets with a smaller amount of processing, or do we want something that is going to have that power to do a very, very large amount of compute processing on our data? So if we know that we're going to be doing things like a large amount of calculations across our data, we may want to look at our compute optimized VMs underpinning it. If we're going, we're just going to have a vast amount of data, and we're not really going to be doing the same volume of queries over that, and we might be doing some basic stuff in aggregating, but it is going to be a large volume of data, we might want to go with the storage optimized option. At the moment, we can also go just dev test, keep the costs low and simple. We just want to play about with it and actually see what we can do with Data Explorer. By all means, come in from there. What we see though is that fixes it with a particular VM size. We don't have any variation over that if we go with the dev test. We don't have any guaranteed SLAs with it as well. And it's all based upon the DL11 v2 Azure VM. But if we look at some of the other options where we can start to see the variation we can get from that. So we're looking at storage optimized, we can see how many cores we want to start looking at from there. If I go to the compute organized one, again, there's a little bit more variation on that. If we look in the largest size I can get with a 16 core machine, and we get the D14 V2 from there. I've also got that option. It's really just giving me the recommended VMs to build up from there. But I do have the option here from the selector to come across and look at any of my Azure VMs. So we can build it up from any VM under the cover. If we know we've got a particular criteria that we want to look for, we can change that and pick out our particular option from there. Let's look at, we'll just go with the extra small, just this 2-core one from there at the moment. The availability zone, again, it really depends upon what you're deploying and where it lives as to, is there an availability zone available for that at the moment? So let's jump past that and look on how it's then going to work on the scaling size of things. So we can look at that and say, I want to control it. My manual scaling from there sets me up with, by default, 2 instances. Again, I can increase that if I wanted that to be, 4 to start with. Of my 4 2-core VMs underpinning it, I can go with that. I can also set it to an optimized auto scale here, where it can give me a range. So I can say I want to, depending upon my load across this, I want to run from somewhere between 2 nodes up to 6 nodes. So if I do start to hit it hard, I will get that additional scale up over the configuration there. As I mentioned, do I want to look at the streaming ingestion option? Is it going to need that low latency for my data to come through into the cluster? If so, then I can switch this on and enable it from here. And also, as I mentioned, on the purge. So do I want that ability to just clear my data completely and know that it's gone for good? Or am I happy with just leaving it with a soft delete at the moment? So additional security options around the encryption of things on there. And again, with the identity for my cluster, if I want to interface with other systems in Azure, how am I doing that? Am I going to use a system identity within Azure AD that's going to identify my cluster across from there? I can set that up if I need to at that point as well. And if I want to control where in my network that goes, I can select that. I can be custom about which particular virtual network do I want to use. I don't actually have one configured within my Azure subscription at the moment, but it just goes through reset. What's your virtual network? What subnet is it? And what's the public IP that is going to use out from that as well. So that gives us a lot of variation on that as well. The basic bit around there, obviously we can tag things as we need to manage our resources more easily. I can go ahead and do that. My standard bit, review and create from there. So either I can deploy it now, or I can build this up and use it as the core of an ARM template if I want this reusable and be able to deploy this multiple times over and over again from there. So that's our basics around how we would set things up with getting our cluster up and running. I want to now take us on to looking at the various ways we can start to load data into our Data Explorer cluster and how we go about querying that. What options do we have through there? And there is, as I hinted at earlier, there's quite a variety of ways that we can get our data into our Data Explorer cluster. The nice bit around the streaming ingestion side of things is that there's a nice close, tight integration with Event Hub. That's really easy then to take our data from there, stream it directly in, and we can do some processing on that as it comes through as well. We can understand what the schema of our source data is, and if we need to do some processing on that, we can set things up so that very quickly when it lands, we can expand it out. If we're bringing in, for example, JSON data, we can expand that out to a tabular data set to make it much easier for us to query ongoing from there. So using that, we can get some processing rates of millions of events per second coming through. We can look at it of saying, well, let's keep our data in our data lake storage, for example. And through that, with Event Grid that can watch for changes in our file structure there. So is there a new file that's arrived into the folder that we're watching? Event Grid allows us to identify that, to trigger it back out through there, again via Event Hubs, to push that into our Data Explorer cluster from there. Where we're hooking things up onto our devices, IoT Hub as well, similar to Event Hub, we can set it up that way to push things directly in to our Azure Data Explorer cluster as well. If we're more batch-based, we might want to then say, well, we'll just use Azure Data Factory, we'll just do things on a scheduled basis, where we can go out to any of our sources, anywhere that you can set up Azure Data Factory to connect to, we can use that as a source. We can then use Azure Data Explorer as our sink for that data. We can also do multi-stage. So from there, we can say, I've taken a basic load into my Data Explorer cluster. I may want to do some processing or do some further joins with that, with other data, before pushing it back into our cluster again as well. So we can do that where we can do it in parts. We can upload things back from our Data Explorer cluster to enrich our data as need be in our batch processing there. So however flexibility that you want to use is available through that as well. And with other third-party products, Kafka, Logstash, all of those can be pushed into our Data Explorer cluster as well. And through the SDKs, you can effectively set up your own processes there as well. You can hook into your own applications, identify what you want to do there, and be able to push those into Azure Data Explorer as well. On the querying side of it, we've got that bit directly in the portal or in other tools to query it. So we might use the Azure Data Explorer interface through the portal and do our querying there. We can set up Azure Data Studio. It now has the Custo kernel directly in there. It was previously, and you may have seen some bits being done with just the KQL magic in Python, which allows you to hook in. You can still do that, you can still set it up that way, but now there is the native Custo kernel for Azure Data Studio as well. And that's when the demos we'll be looking at to see how to do things that way. If our data's already in Azure Data Lake, we don't have to ingest that separately into Azure Data Explorer. We can use the querying power of our cluster and hook it up to external tables. So you're looking directly into perhaps your folder structure, identifying how it's partitioned. So if your folder structure is set up with the date, for example, through year, month, day, hour, minute, whatever level of partitioning is in there, being able to identify your top level of your folder structure and then express the fact that the rest of it down there is your partitioning structure. allows you to then hook onto that and query across multiple files at once as an external table definition on there as well. And the web app part of Azure Data Explorer gives you all that same sort of functionality and feature set. It looks quite similar to what the experience is in Azure Data Studio as well, with the additional bit that it can give us some dashboards in there. So we can actually use that as something as a visualization tool into our data as well. And it might be something there that, you know, we see the format of that. We can then hook in also things like Power BI into our Data Explorer cluster as well, so we can get more advanced visualizations. There's also, you know, things like you know, Kibana as well and Grafana that we can hook in if we want to see those visualizations, those live data feeds from things on there. We can hook those in as well. Okay, so let's get into the more fun stuff around this and actually see how we would go about getting some data into our Data Explorer cluster and doing some queries with that. Now I'm going to use Azure Data Studio to do this. And the first bit you need to do when you've got that, you need to install the Custo extension to be able to, you know, use that kernel natively. You'll get that from using the extension manager. Select search for just Custo, follow the prompts on there, and that will then give you your Custo kernel to be able to use and connect it directly. So the first bit you've got once you've got the Custo kernel enabled is to make your connection. So we want to set it up on here where we have that opportunity of going, you know, what's my kernel, and put the connection string in from here. The first one I'm going to connect to on this is a standard test cluster that Microsoft have made available. This is a great point for getting in and starting to learn the basics of it, because they give you multiple data sets to query with here, which is really, really cool. And they're all just available. You can just go straight there, hook up to it, start playing about with it, and it's no cost to you to do that. You don't need to set up any Azure infrastructure for this part. You really just need the connection to set up through there into your Data Explorer cluster. Set the authentication type with Azure AD with MFA support. You'll use your Microsoft account to log in, but it then gives you this part here with the My Data Explorer cluster.westus.custo.windows.net. That's the standard one to hook into there. Once you've got that, as you can see, we've then got the ability to set our kernel correctly and set it up to the demo cluster. So the actual demo cluster is help.custo.windows.net. As you can see, that's the one that I've got connected to up on here as well. So let's see what we have. Now the format you'll start to see with the Custo queries is where it is what would be in the SQL world, the equivalent of a DDL command. It will be this dot before the command that's put in from there. So in this one, my show tables, we've got the connection through there. It's just going to tell me, you know, what's available to me to use here. So we can see some of the stuff that they've got set up in the samples. There's things like the US storm events data source, so giving us a lot of rich information around that. There's now some interesting stuff around COVID-19 events. There's some stuff around population data. So there's a nice number of different things to query through from there and be able to start playing with things. When we get into actually querying the data, the format of it, and we'll cover this in a bit more detail with some of the more detailed stuff that I'll go into, but you basically start from the table name, and then each part of your query is separated by the pipe character here. So again, I can start to look at narrowing it down in the same way of a SQL query. I'm putting my predicates in here. So for this one, I want to look at the storm events and only see the ones that resulted in a water spout. And then my summarize command is like, you know, a group by in a SQL query. So I'm just going to go, give me the count of all the event types that included a water spout. And you can see out of that data set, I've got 288 individual events that generated that particular event type. So that's some basic stuff there on the standard cluster that Microsoft have made available. But let's start looking at our own one, and let's start looking at how we can then actually ingest some data. So let's do something a bit more interesting. So I'm going to set up something here to do a bit of streaming data ingestion. And I'm going to use a couple of Azure SQL databases as my sources. So what I've got set up is within the diagnostic area of my databases, I've got this ability here to say, let me stream that out to an event hub. And that's going to be my interface. I'm going to push those out to the event hub, and then the event hub is going to be the part that plays it back in to my Azure Data Explorer cluster. So it's a fairly easy bit to set up there. I've got the event hub set up. It's in there. I get a particular namespace for that. I just define that, my event hub name, and a policy name that goes with that. I'm not going to dive into how you set up the event hub. It's reasonably straightforward to follow it through. Easy to go ahead and do that. And all I'm doing is just doing the basic metrics. So what that's going to give me, if I come back to this, it's the similar information that's going to produce this chart on here for the metrics. So you can see I've got a bit of load that's been running across my database for the last few hours, a little bit of a variation on it over time there. So it's going to give us something a bit of interest with the data when we look at that. So again, on this one, I've now connected to my own cluster that I've got set up here. I'm going to go and start doing the preparation before we get into actually being able to query the data. I've got to plan it properly and pull out what I'm going to load it into. So my first table, this is going to be my end table. This is what my final view of the data is going to look like. And I'm going to have the timestamp of when the event happened. I'm going to have the server name that it was related to, the database name, and then my particular metric. So that information as to, is it the DTU consumption? Is it the CPU consumption? Whatever through from there. Nice and straightforward. It's going to give me a count, a total, a minimum, a maximum, an average over there. And it's going to tell me what the time frame for that measurement is. So, what sort of period was that over? So let's create that first of all as just our empty table. Now, the way that it's going to push this through is the metrics will be sent to the Event Hub, and from the Event Hub to Azure Data Explorer as a JSON record. So I need to do some way where I'm going to map my JSON back out to that tabular format. So what I'm going to do is I'm going to say, first of all, my raw records are initially going to land in this diagnostic raw records table, and they're going to be in a dynamic data type. So I haven't specified them as being, they're not quite down to being a string or an integer or a floating point or whatever as yet. It's still dynamic, and that's basically the mapping for the JSON data type. Now that table is really just an intermediate step so that we can then translate it. So I don't need to actually have any retention over the data in that one. So I'm going to use my alter statement here on the table. I'm going to set my policy retention to 0 days. So basically just saying, I don't care about saving things from there. It's going to just pass straight through it. We don't have to store it. And because it's coming from Event Hub, it's going to be streaming into there. So again, I'm going to tell it that this table will accept streaming ingestion. So again, straightforward from there. Now, the next step I need to do is to tell it out of that JSON record, which parts of the JSON am I interested in? It's a reasonably straightforward structure that comes through. It's a well-defined one from the Azure metrics. So we can use this with a column called records, and it's going to be that records as being the header part of the JSON statement that's coming through. So that's really just telling me what my first bit is going to look like. Now, how I now expand that out from the JSON record this is where we start getting interesting, start seeing some more of the detailed syntax on the KQL language. So I'm going to apply a function that will run every time there's a record lands in that source table. And what it's going to do, it's going to start off with taking my source table here, my diagnostic raw records, and it's going to do an expansion of the JSON record. So what it's going to do is expand out what was called records initially, and it's going to put that now into a bit called events. Nice and straightforward from there. I've got a where clause in it of basically if the metric name value is empty, so it's a null, it's going to give me no value. I'm going to throw it away. So I've just got a where is not empty on that one to ensure that. Now the project command on here, that's effectively the equivalent of a select. That's just telling me which columns I'm interested in. And this is where I again start to process out my JSON record. So I'm going to go the time property from there. I'm going to put that into my timestamp column. My resource ID, so that's my Azure resource ID that comes through, is that record that's split down all the way through of what you've actually got. So it goes through from things like your resource group to your resource type of being Azure SQL. It goes to your server, to your database, etc., all the way down from there. And it's a very standard structure. It's all separated with a slash in there. I don't need the full resource ID. I'm going to throw that away. It's offering me no value. I want to extract out the server name and the database name parts from that. And that's fairly standard. If you've used things like SQL, this all would look reasonably straightforward to you by using a substring, the length, a split function of where I'm going to split it on, which part am I going to split it to, that sort of thing. So I know how many components I've got into this resource ID. I can pick out those specific parts of it. So that gives me something nice and straightforward from there. The rest of it are all high-level properties in my JSON. So again, the metric and then the actual values that are coming out from there, they're all fairly straightforward from that. So I can go ahead, create that function, and it's ready to go. And the final step on it is then saying, okay, my destination table, so my diagnostic metrics, which is going to be the endpoint of where this all lands, I need to give that a policy which says, have a look for things on the raw records, query them using the function that we've provided there, make sure that's enabled so it's always looking for that, and making it a transactional thing as well. So that then tells this table to say, I'm going to keep looking at that table, effectively keep pulling that table. If there's a record that arrives, I'm going to apply the function to it. I'm going to use that to insert into me as a table there as well. So that's the core bits now set up. So from the Data Explorer side, it's now set there. It's ready to go when data arrives to be able to upload that. We now need to add the plumbing, which pulls together the bit from Event Hub into our Data Explorer database there as well. So let me come back to the Azure portal. I want to come back up to here and my Data Explorer cluster. And we'll jump into that specifically. I'm going to look at creating a data connection. And that's coming from Event Hub. And the data connection name, let me just shift that to the side so we can get the references from here. So that's my diagnostic metrics connection. It's pointing to my Event Hub and my metrics one. And the appropriate consumer from there. I don't have to set any properties on this, and it's not compressed at this stage, so it's uncompressed data going through from there. and I need to tell it which table it's going to. So this one where it's going into, this is the raw one. So it's the table that's got the JSON definition. So that's my raw records. The data format is JSON, and then it's looking for the mapping name, which is the bit that's telling it, how does that fit? Which part of the JSON goes into the actual dynamic field property, which is the bit that we define right at the start of the table definition there as well. That sets everything up from there. I can now say go ahead and create that data connection. It will check things up from that. It will make all the connections available. And after a little bit of time, it will start to push that through. We'll see that once it's in there, it looks as though it's already got that that provided. It hasn't cleaned up on that one. It will go from there. We're not actually going to be consuming and querying the data from this one. That's really just taking you through the steps from there. That's because I didn't clean up properly after the last time. But we'll see that at this point, it's telling me that we don't have anything available in from there, and that's okay. Now, the other way we can do this is we're going to have a look at how we can ingest directly from Blob storage. So again, if I come into my Data Explorer cluster in from here, so we've got it here with, and if I refresh that, you'll see that I've now got the tables that we created defined in there along with the function. So we've got a little bit of an object explorer happening there as well. But I can say I want to ingest new data as well. So again, same cluster and database. I'm going to create a new table. And this one, we'll give it a name in there and identify that it's coming from Blob, but we're going to be the, actually spelled that wrong, so let me get this right, otherwise the rest of my queries will fail miserably. And that's going to come from a Blob container. Now, what I'm going to do is grab separately here, I'm going to generate a shared access token to my Blob storage. So again, in the same way with my metrics bit here, my diagnostic settings in here, I can come where I had it set to go to Event Hub. I can also include another bit in here to direct it to just a storage account. So I've got my storage account here. It's the same information being sent to there. I just need to grab the shared access signature and the URL link for that. Pop that in there. And then it's identified. It's been able to read some of that in from here. I can come in and say, well, let me edit my schema from this. And I can decide which parts of this I want to include or not include within the details. So I can get the same information from here in my samples of the count and the total and everything from those various metrics. I can look at the metric names and details from there. Everything in that looks good. It automatically creates for me, again, the same mapping stuff. If that JSON had additional sub parts to additional arrays within there, I can change the number of nesting levels so that it can go down the tree and identify things from that way. So it's quite smart around that part of things from there. So I can say on this one, yeah, go ahead, just ingest that from me. So what that's doing now is it's just going to my Blob storage and effectively just pulling that in from there. It's doing the transformation on the data as it loads it in, and it'll populate that into my table at the end of it. So it's found that there are 7 blobs. So there were 7 files with data that were relevant into there, and it's pulled those all in successfully. Excellent. So we're all good from that point. So let's have a look at what we can do with that data now. So you can see I've got my Blob diagnostic metrics table that's existing in here. The nice bit around the portal here, so the Data Explorer portal, is I can have my queries saved separately. So my whole query definitions, I can save them out. I can pull them in from a new file in here to be able to run through and deal with that. Now, the other bit where you've got multiple queries together in the window, if you highlight just the text of a query, or if you have the cursor within that, it'll only run that part when it's ready to go. So let's see, out of those 7 files, we got a total of 3,829 values that have come through from that. So let's look at some sample of that data. Now, at that point in time, I did a basic ingest in this one. So instead of the processing that I did with the function on the Event Hub part to strip out things like the server name and database name, I didn't do that in the ingestion part here. So what I'm going to do is use some of the functions within KQL to actually do that for me. And this extend is really like adding in a calculated column into my table. So I'm going to do the same bit here. I'm going to pull out the database name still from the resource ID, and it's using the same formula that I was using previously with that. And as I mentioned previously, there was the project command, which says the equivalent of a select. I can do it this way as well and say project away with the resource ID. And what that's going to do is it's going to give me all the columns except resource ID, which is kind of cool that way. If you don't want to select all the columns, you only want to drop one out of a large number of columns, instead of having to write everyone individually, you can say, well, everything except this one. And what we'll do is we'll just have the first 100 records out of that table at the moment. So you can see it's pulled that out. It's now giving me my database name part out of here rather than the whole Azure resource ID, but it's got everything else within there. It's got the sample time, the metric name, excuse me, and the data values that are relevant with it. In this format, it's all very well. It's not really the most useful piece of information to deal with. So let's see what we can do to give us a little bit more value out of this. So again, we're going to start from our same table. We're going to use the extend again, just so I can pull out my database name. And then the summarize is kind of like our group by. So what I'm going to do is, rather than looking at this of being such a frequent sample on the data, what I'm going to do is group it up into 15-minute averages over what's been happening there. And I'm going to group it up by the database name because I've got multiple databases, and by the metric name as well. So I can see what's happening for those various metrics over that. And my bin command here is the bit that then says, here's the grain of time that I want to group everything into. Again, on this one, I'm only taking out the database name, the metric name, the time, which is then going to be the start of that grouping, and the value of my average value. So this, whatever the value was, and they're averaged over the period, and sort that by the same bits as well. So now we're starting to get something, a little bit more useful. We can see from this with the timestamps in here, we can see those 15-minute intervals into everything through there. And depending upon the particular metrics, we'll see that some of them have got values, some of them don't. It really depends on what my database was doing at the time from there. So what do we actually have? Again, I can start to use things like distinct into the query here, and I can see all of the various metrics that I'm interested in. So this is everything that exists in there. And I can also put this on to anything I've then defined, which is the nice bit. As you go through that, where I've added database name, I can then still do a distinct on that and make use of that in further parts of the query as well. So my 2 databases out of here are important in there. I can also build out derived tables within it as well. So the let statement here lets me define a data table, give it a column name, and give it some particular sets of values. So if I want to filter this down and say I only want to look at the DTU related metrics coming out from there, I can do that, and then I can join that back to my previous table, And again, I can still do my extend on there to get the database name property from it. I can do my aggregation again up into my 15-minute buckets. And I can look out as to just which particular values we're looking at there. So instead of that full set that we had before, I've now only got the 3 metrics. I've got my DTUs, my DTU limit, and my DTU consumption %. And we can see that for each timestamp here, I've then got those values and the values for each of the databases. So we can see I'm starting to get a bit more value out of that, and really great, quick performance there to gather that. The other nice bit within here, now it doesn't work within the Azure Data Studio version at the moment. There was some bits where they had it with the magic within Python, but the Custo kernel itself isn't enabling this. But I can, instead of having that tabular output from there, I can immediately tell it to render it as a chart for me. So what I can start to see is over my, and it's kind of jagged because of my 15-minute aggregations in there, but we can see how that's varied for my 2 databases over time from there, with the values of that particular metric grouped in over time. What if I don't want to see those values? What if I want to change those again as well? So looking at my values, I can see where I've got some of them creeping up to nearly 100%, a lot around about the 50%, and a few dropping down under the 25%. So let's make use of that. Let's change this to 25% for the first bucket. So any of those bits where the average sat under 25%, I'm going to replace that value just with a replacement value in here of 1, my bucket number of 1. Again, if it's greater than 25 but less than 50, it should come in with bucket 2, and above that, it should come in with bucket 4. So again, we can start to see from that we've got my first database here. That's pretty much all the sample periods it's been under 25. Great, it sits all in bucket 1. Whereas my other one here, I said a bit of variation in it. It's been sometimes where it's averaged below 25, sometimes it's gone up to the below 50, and we can see that changes over there. So we can start to manipulate our data quite considerably around that as well. So how do we consume the insights and information that we've got from there? So if we can go back, we'll have a look back on our Data Explorer query tool and dashboards there. We can take those queries and we can start to get some basic dashboarding out from it as well, which can be cool based on that level. Most of your visualization tools with Power BI, Tableau, Grafana, Kibana, they can all natively connect in and consume the data out from your Data Explorer cluster from there. And because you've got an ODBC connection endpoint into your Data Explorer cluster, effectively any custom application is easy enough to hook in there as well and be able to consume that. So let's jump back in and we can come to our dashboards in here. Now I've got one that I've had set up previously. There's been a few changes in this, so it's not quite hooking in correctly. So let's see how we can fix that. If I look at this and see what my query is doing, we can see it's actually hooking into my diagnostic metrics. So let me change that. And the other bit to be aware of is that it is case sensitive on the names as well. So I can come in and do check on this, make sure that's all okay. Great, that's given me something in there. I'm happy with that side of things. I know that that's now going to replace that query in there. So I can come back in. I can reset this with an edit on there, edit my bit on here. I can now change this part as well. And I've got a network error on that. That's my connection, my data source connection has changed as well. like that. Cool. So now we see we've got my my dashboard card now coming through on there as well. Again, on this one, it's going to have, again, that old connection in there. I can come in, fix up my case sensitive stuff. And the other bit to be aware of, on this one, instead of timestamp, I had it as time. However, that's a reserved word, so I need to, just identify that out as being the actual column name and not the reserved word on that. I can do that and apply my changes. And that one doesn't have, that's on that particular metric. Let me grab a different metric name. How about I take CPU percentage.
Hi, Martin. Don't want to put some pressure, but we run out of time, so
change that. But I can then define that, and obviously within there I can include things like the render as a time chart and things as well. Awesome. So that really gets me to everywhere I wanted to go from there. To finish things off, I guess I'll open it up, and if anyone has any questions around that.